the inverse trigonometric functions. And the first function that we're going to look at is the inverse sine or arc sine of x. Okay, so we have this function y is equal to the arc sine of x, and we want to find out what is the derivative of the arc sine of x. All right, so we want to know what is the derivative with respect to x of the arc sine of x. That's the question. Okay, well, the easiest way to do this is to take the sine of both sides, right? If I take the sine of the left-hand side, I'm going to take the sine of y is equal to, well, the sine of the arc sine, if I take the sine of an arc sine, what I'm doing is I'm compositing two functions that are inverses of each other, and the result of that is just going to be the input, which is x. So I end up with the sine of y is equal to x. And this is better because now I can use implicit differentiation and I know the derivative of the sine. So now what we're going to do is we're going to use implicit differentiation and take the derivative of the left-hand side and the right-hand side. Okay, so I'm actually going to take the derivative with respect to x of my left-hand side, which is the sine of y, and that's equal to the derivative with respect to x of my right-hand side, which is x. So the derivative of the sine is the cosine, and I'm actually taking the derivative of the sine of y with respect to y, and I chain rule, times the derivative of y with respect to x, which is y prime. And on the right-hand side, the derivative of x is, with respect to x, is 1. Now remember, I'm trying to find y prime, which is the derivative of the arc sine of x. So I'm going to divide both sides by the cosine y, and I get y prime is 1 over the cosine of y. Well, I'm close, but I don't want the derivative of, with respect, I don't want my derivative to be with respect to y, or I want it to have, the formula to have x's in it, not y's, okay? So I want to rewrite this as a function of x, not a function of y. And I happen to know, let's see, that there is a relationship between x and y right there, okay? That the sine of y is equal to x, all right? What, therefore, is the cosine of y? So let me change up colors a little bit. I'm going to go to blue. Using this information here, what is the cosine of y? Well, I know that the sine squared y plus the cosine squared y is equal to 1. That's one of our first trigonometric identities. And I'm going to replace the sine of y with x, because as we see here, the sine of y is equal to x. So I'm going to replace this sine of y squared, okay, and I'm going to call it x squared because the sine of y equals x. So this is x, this is x squared plus the cosine squared y equals 1, and I'm trying to find the cosine of y. So I subtract x squared from both sides, and I have the cosine squared y is equal to 1 minus x squared. And if I take the square root of both sides, I have the cosine y is equal to the square root of 1 minus x squared. And what I'm going to do now is I'm going to replace this 1 minus x squared for the cosine of y here, and I'm going to go back to the black, and I have that y prime is equal to 1 over the square root of 1 minus x squared. So this is the derivative of the arc sine function. Let's put this up here. So the derivative with respect to x of the arc sine function is 1 over the square root of 1 minus x squared. So So I'm going to leave it to you to derive the derivative of the sine function. Using this, how would you find the derivative of the sine function? All right, so let me add a page below. Oh, I did mean cosine, thank you. Yeah, sorry. Okay, so our function y is now the cosine, arc cosine actually, the arc cosine of x, and I want you to find the derivative with respect to x of the arc cosine of x. And you're going to use the same idea. You're going to take the cosine of both sides. What is that? And let me go back. I'm going to go back to this other page so you can see what I did here. And I'm going to shrink it down so you can look at it while you're working it out. I'm going to take this and I'm going to shrink this down. It disappears for a minute while I resize it. And I'm going to move it back up here. And I'm going to go back to the page where I want you to work. And let me grab this, copy it, and I'm going to go back here. Okay, so I want you to work out the derivative of the arc cosine of x, and I'm going to leave this up so you can see how I did it for the arc sine of x and see how you do.